Itarusha. Few tips on chemistry. What does indicator conceptual means? In chemistry, an indicator is a substance that undergoes a distinct observable change when the conditions in its surroundings change. Indicators are commonly used in analytical chemistry to detect the presence of certain substances or to monitor chemical reactions. Here's a conceptual explanation of indicators in chemistry. Definition: an indicator is a substance that exhibits a noticeable change in color, pH, conductivity, or other physical or chemical properties in response to changes in its environment. Types of indicators. Color indicators. These indicators change color in response to changes in pH or the presence of specific ions. For example, litmus paper turns red in acidic solutions and blue in basic solutions. pH indicators. These indicators change color at specific pH levels. For instance, phenolphthalein turns pink in basic solutions with a pH above 8.2. Complexation indicators. These indicators form colored complexes with certain ions, leading to observable color changes. For example, EDTA, ethylenediamine tetrashic acid, forms a complex with metal ions, resulting in color changes in titration reactions. Redox indicators. These indicators change color in response to changes in oxidation reduction, redox reactions. For example, potassium permanganate, KMnO4, is used as a redox indicator in titrations. Applications. Indicators are widely used in titration experiments to determine the endpoint of a reaction. They can be used to monitor the progress of chemical reactions, such as acid-base or oxidation reduction reactions. In analytical chemistry, indicators are used to detect the presence or absence of specific substances in a sample. Indicators are also used in environmental monitoring to assess water quality and pollution levels. Factors affecting indicator choice. The choice of indicator depends on the type of reaction being studied, the pH range of interest, and the specific ions or substances present. Indicators should have a sharp and distinct color change, making it easy to determine the endpoint of a reaction accurately. In summary, indicators play a crucial role in chemistry by providing observable signals of chemical changes. Understanding their properties and applications is essential for conducting accurate experiments and analyses in various fields of chemistry. Reaction of sodium hydroxide is an alkali. Yes, that's correct. Sodium hydroxide, NaOH, is indeed an alkali. Alkalis are substances that dissociate in water to produce hydroxide ions, OH, and have a pH greater than 7. Sodium hydroxide is a strong alkali and a highly caustic base. When dissolved in water, it completely ionizes to form sodium ions, Na+, and hydroxide ions, OH. Due to its alkaline nature, sodium hydroxide is commonly used in various industrial and laboratory applications, such as in the production of soap, paper, textiles, and as a drain cleaner. State the color change when excess aqueous sodium hydroxide is added to a solution of methyl orange in acid. When excess aqueous sodium hydroxide, NaOH, is added to a solution of methyl orange in acid, the color change observed is from red to yellow. Methyl orange is an acid-base indicator that undergoes a distinct color change depending on the pH of the solution. In an acidic solution, methyl orange appears red, while in a basic solution, it turns yellow. The addition of excess sodium hydroxide to the acidic solution causes the pH to increase, resulting in the indicator changing from red to yellow, indicating the presence of a basic solution. pH value of alkali. The pH value of an alkali, also known as a base, typically ranges from 8 to 14 on the pH scale. Alkalis are substances that dissociate in water to produce hydroxide ions, OH, and have a pH greater than 7. The higher the concentration of hydroxide ions in a solution, the higher its pH value. Here's how the pH values correspond to the strength of an alkali solution. A pH of 8 to 10 indicates a weak alkali. A pH of 10 to 12 indicates a moderate alkali. A pH of 12 to 14 indicates a strong alkali. It's important to note that pH values are logarithmic, meaning each whole number change on the pH scale represents a tenfold difference in the concentration of hydrogen ions, H+, or hydroxide ions, OH, in a solution. Therefore, a solution with a pH of 14 is 10 times more alkaline than a solution with a pH of 13, and 100 times more alkaline than a solution with a pH of 12, and so on. State the color change when excess aqueous sodium hydroxide is added to a solution of litmus in dilute sulfuric acid. When excess aqueous sodium hydroxide, NaOH, is added to a solution of litmus in dilute sulfuric acid, the color change observed is from red to blue. Litmus is a natural pH indicator that undergoes a color change depending on the acidity or alkalinity of the solution. In acidic solutions, litmus appears red, indicating the presence of hydrogen ions H+. When excess sodium hydroxide is added to the acidic solution, the pH increases due to the presence of hydroxide ions OH from the sodium hydroxide. This increase in pH causes litmus to change from red to blue, indicating the formation of a basic solution. Therefore, the color change observed in this reaction is from red, acidic, to blue, basic. Reaction with zinc oxide? Product 1 zinc chloride and product 2 water. What is observation? The reaction between zinc oxide, ZnO, and hydrochloric acid, HCl, yields two products, zinc chloride, ZnCl2, and water, H2O. Here's the balanced chemical equation for the reaction. ZnO plus 2HCl ZnCl2 plus H2O. Now, let's examine the observations for this reaction. Zinc chloride, ZnCl2. Zinc chloride is a white crystalline solid. It is soluble in water, so it dissolves completely in the aqueous solution. Depending on the concentration of the solution, the appearance may range from clear to slightly cloudy due to the dissolved zinc chloride. Water, H2O. Water is a colorless, odorless liquid. It is formed as a product of the reaction and remains in the solution. There are typically no visible changes associated with the formation of water. Overall observation. The reaction between zinc oxide and hydrochloric acid results in the formation of a clear or slightly cloudy solution, depending on the concentration of the zinc chloride solution. The solution may become warm due to the exothermic nature of the reaction. If excess zinc oxide is present, some undissolved solid may remain at the bottom of the container. These observations are consistent with the chemical equation and the properties of the reactants and products involved in the reaction. Nitric acid contains the nitrate ion. Use the word to describe the test for nitrate ions. Aluminium, ammonia, chloride, copper, hydroxide, iron, oxygen, sulfate. Put the sample in a test tube, then add aqueous sodium. Fill. Then add fill. Warm gently. A gas is produced. The name of the gas is? The word that can be used to describe the test for nitrate ions is ammonia. Here's how the test for nitrate ions is conducted. Put the sample containing the nitrate ions in a test tube. Add aqueous sodium hydroxide and AOH to the test tube. Then add aluminum filings Al to the mixture. Warm the mixture gently. If nitrate ions are present in the sample, the reaction produces ammonia gas, NH3. This gas can be identified by its distinctive pungent smell. The reaction involved in this test is the reduction of nitrate ions by aluminum in the presence of a strong base, sodium hydroxide. 3 no 3, Antàrtida, 8 S, i 5 Antàrtida, u 18H2O, L, 3NH3, G, 8 Al, O, 4, Antàrtida. So, the gas produced in this test for nitrate ions is ammonia, NH3. Sodium hydrogen sulfate NaSO4 dissolve in water to produce an aqueous solution, X containing Na+, H+, SO4 ions. State the observation when the following tests are done. Copper 2 oxide is warmed with an excess of X. When copper 2 oxide CuO is warmed with an excess of the aqueous solution X containing Na+, H+, and SO4 ions sodium hydrogen sulfate, the following observations can be made. Color change. Initially, copper 2 oxide black reacts with the acid solution X. As the reaction progresses, the color of the solution may change, depending on the concentration of copper ions formed. Formation of copper sulfate. The reaction between copper 2 oxide and sulfuric acid from sodium hydrogen sulfate results in the formation of copper sulfate, CuSO4. This compound is soluble in water and forms a blue-colored solution. Effervescence. If the reaction produces any gas, such as carbon dioxide, CO2, due to the release of hydrogen ions from the acid, effervescence or bubbling may be observed. Overall, the observation of warming copper 2 oxide with an excess of the aqueous solution X would likely include the formation of a blue-colored solution due to the production of copper sulfate. Additionally, any effervescence or color changes may also be noted during the reaction. Have good understanding of fundamentals concept. Good reading. Keep focus on always.